Let's see how fast we can do this quiz for this week. Which of the following increases the rate of the reaction? Increasing the surface area increases the rate of the reaction, yes. The addition of catalysts, yes. The increasing the concentration of reactants only, products, no, yes. Increasing the temperature, yes. Addition of the catalyst also, yes. But about the increasing the volume, it has no effect here. The effect is only in gases, and if you increase the volume, you decrease the pressure anyway of the gas, so the rate decreases, not increases. Which of the following factors? So this is correct. We always remember that the surface area is inversely proportional to the particle size. So if it's powdered, substance powdered, so it means the particle size decreases, the surface area will increase and the rate increases, and vice versa. So if you increase the particle size, like we said, you change it from the powder into lump. This is the vice versa, so it means the particle size has been increased, so surface area has decreased and the rate has decreased. So this one is correct as well. Which of the following affects the rate of the chemical reaction? The color has no effect, and there is an effect of the concentration of the product. No. The reactants only concentration, and the temperature and the surface area. These are the factors affecting the rate of the chemical reaction. How does the increase in the concentration of the reactant affect the rate of the reaction? Imagine you have two rooms. One has two children hitting each other and running everywhere, and one has 10 children. The more concentration means that more children here. So the concentration is high means more collision between them and each other. And since the rate of the reaction increases by increasing the collisions, so more collisions due to more concentration is causing more rate of the reaction. So it increases the frequency of collisions and thus increases the rate of the reaction. This is the only correct one. A block of wood burns with oxygen in the air at certain, so the wood burns in the presence of oxygen to form carbon dioxide and water and heat. What will increase the rate of the reaction? Will increase the rate of the reaction by grinding the wood and cutting it into smaller pieces, because both of them has increased the surface area. Replacing air by pure oxygen now, because you are making the reaction with oxygen only, this makes the reaction faster. Why? Because you need oxygen, you don't need the rest of the gases. Simple, like with this one in the hospital, the guy is on the bed, they don't give him air in that cylinder. They give him oxygen because he needs the oxygen, so the concentration of oxygen increases. The carbon dioxide does not do that. You don't need carbon dioxide to burn. In the opposite, it's extinguishing the fire. So carbon dioxide in the extinguishers are using to decrease the fire or extinguish the fire. So it's not used. And nitrogen is an inert gas which does not do anything good or bad. So grinding the wood and cutting the block of wood and replacing by pure oxygen is the correct answer. Which of the following best defines the chemical kinetics? It is a study of the reaction rates. In this reaction, I'm trying to see if the reaction is fast or slow by the formation of a precipitate. In this reaction, a solid sulfur is formed. So the sulfur in the solid form has a yellow color. It will form, and this precipitate makes you not be able to see it. So if you are, this is the beaker, and you are looking here from the top, and then there is an X sign here. So when the precipitate is formed, so it starts to form, and the faster it forms, the faster that the X is disappearing. So the faster the disappearing of the X make in this under the solution makes it faster reaction. If the precipitate is formed slower and the disappearance is slower, means the rate of the reaction is lower. This is the third method of measuring the rate of the reaction after change in the volume and change in the mass of the reactants. So why is necessary to keep the total volume same in all experiments? Because you want to make a fair experiment. If you did the same experiment with a different amount of water, then you will be able to see the X easily. Why? Because there is less water. So the amount of water has to be both the same so that there is fair comparison. If the reaction is repeated at 40 degrees, instead of having it happening at the beginning at 20 degrees, means that you have increased the temperature, which means that the rate of the reaction will increase. So the rate of reaction increases because the particles move faster. You know that the kinetic energy increases and the frequency of the collisions will increase also. This is the effect of increasing temperature on the rate of the reaction. The cross disappears because the sulfur precipitate has formed, and if the experiment is repeated using 250 centimeter cube, this means more volume. So if you have more volume, it will be more difficult to see the X, not because of the precipitate, because of all this water here. So it will be more difficult. It will take longer to see the X disappear. Dilute HCl was added to XX calcium carbonate. This is the second method of measurement of rate of reaction, which is decreasing in the mass. I have here calcium carbonate reacts with the acid And when you put the acid on the calcium carbonate, it forms carbon dioxide and calcium chloride. The calcium chloride stays inside here, but the carbon dioxide comes out as the form of a gas. So if you want to see the decrease in the mass, you have to let this go out. When it goes out, the mass of the total mass on the balance will start to decrease. So by the time it starts to goes down, you need the carbon dioxide to go outside. So that's why you need this to be open. But if you kept it open, the addition of the HCl will cause a gas splash, which is dangerous. It might hurt somebody. So it's better to put a cotton wool because this allows the carbon dioxide to go out, but at the same time does not cause the gas splash. So it allows the gas to escape, but it does not allow the gas to splash and hurt any person. If you put a stopper, a normal stopper instead of the cotton wool, then the gas will not be going out. So the mass will not decrease because whatever carbon dioxide is produced, it will stay inside the glass. So which is the release of carbon dioxide is causes the mass to decrease, which is the correct curve here. This is the original curve. So if this is the original curve, what should happen? The rate of the reaction will be faster. The rate of the reaction will be faster. The curve is asking about the curve. So what happens when you change the temperature? So when you change the temperature, the rate of the reaction will be faster. So this means a steeper curve. So the curve will be steeper. Take care, this is steeper curve. And the rate in the increase of the volume, the first method, the curve is up. If it's steeper, it is up. If it's steeper, it's up here because it's decreasing. So if it is steeper, it will be down. You can see that it's steeper easily, but it is less steep here in the blue and steeper in the red one. And here we don't choose the last one because we don't choose the first one. We don't choose the first one because in the first one, the amount of the gas differs. So this is the original curve, and this is the different volume here. Didn't do anything, different mass here. We didn't do anything to make the amount of mass different. Only the rate of the reaction changes. In this Boltzmann curve, Maxwell-Boltzmann curve, as you increase the temperature, the curve shifts to the right. So the curve at the beginning is here, and then if you increase the temperature, so this is the curve, then it starts to shift to some of the gas which is here, some of the gas which is here shifts. If you want to see how this happens, I'll try to move this one for you. So the curve will start to shift. So this one shifts, it goes right. So it goes like that. So if this is the first one, when it shifts, it becomes like this one. It has moved like this one and becomes higher. And then if you do it again, then it will become, so it becomes higher, like it becomes like this one. So this is the T2. So if this was T1, this will be T2. And then when you do it one more time, it will come higher even. So it will become like that. It will become like that. So the curve shifts to the right. Why it shifts to the right? Because more particles will have higher kinetic energy. So the number of particles with low kinetic energy will decrease, and the number of particles with higher kinetic energy increases. So it increases to the right. And now, based on the collision theory decrease in the concentration, remember the grids in the room running and colliding, the decreasing the concentration decreases the rate of the reaction because the decreasing in the collisions. Based on the collision theory, a decrease in the temperature of the reaction also decreases the rate of the reaction because this time the effective collision is less. There is difference between a collision frequency and collision effective collision. So we may be playing box with somebody and hitting someone many times. So this is too much frequency, but maybe you are not giving him the KO. So the KO is the effective collision. This is a collision which makes a reaction. So you don't need only a lot of collisions. You need collisions which has certain energy above the activation energy. If it's not above the activation energy, if it's above the activation energy, then it will cause the reaction. Then it will cause the reaction. If it is less than the activation energy, then it will not cause the reaction. That's why you need the reaction to be faster. Then the temperature increases the effective collision, not only the frequency of the collision. While in the concentration increase and the pressure increase and the concentration pressure and pressure increase, it only causes the increase in the frequency, does not affect the effective collision. Now there are three curves in this reaction. So I have the first curve, which is at P. You need to find out the original curve every time in the reaction, otherwise you will not be able to answer. So let's see, this is the C, which is the original curve. How did you know? Because when I looked at B, I saw that the B is below. So B here is starting below. It becomes higher than it at the end, but it is at the end at the beginning was below, so it is B. It gives me more volume, but it is lower rate. It's less steep or it's steeper. I can see that it is less steep. So it is lower rate of the reaction, and then the C is higher rate because it is more rate and even higher volume. It also ended with B. So it ended with B, so it is higher rate and higher volume. So it's higher rate and higher volume. That's the C. So at lower temperature, what happened when you have a lower temperature? When you have a lower temperature, so again, you have lower temperature, and lower temperature is meaning that it is less rate, so it is the B because it is less steep. And then the lower concentration of hydrochloric acid. Mr. Lower concentration means lower rate of reaction, but lower rate of reaction should not produce more. It should not produce more of the quantity because here P will produce more of the quantity. It should be the same quantity. That's why I choose C. Using lumps means the rate of the reaction has decreased. Why? Because the surface area has decreased, because the particle size has become bigger. Instead of powder, it become lumps. That's why rate decreases, so it is B. And then the addition of a catalyst, the addition of, let's make the B pink again, and then the addition of catalyst faster, so the only one faster is the A. The graph below shows the volume of oxygen formed. Choose the correct answer. The point X is called an anomaly. Anomaly is that you may make a mistake during the exam. Like look into one of your colleagues while you are measuring the volume, so the volume does not come correct, so it is an anomaly. It's out of the correct numbers. So all are correct and one is only wrong. This is an anomaly because there is a mistake here. So it's a mistake like you are reading the volume, so you are reading the volume in a wrong way. What volume of oxygen is collected after 10 seconds? If we look at 10 seconds and come up, we'll see that the volume is 15. So it is 15. How long does it take to collect 19 centimeter? So if you come here at the volume and look at 19, we'll come here and then come down. So we'll come down at 15 seconds. So this is 15 seconds. And what caused the reaction to stop? The only thing that will make the reaction stop is the reactants are totally consumed. So a student wants to study the speed of reaction between zinc and hydrochloric acid. This is the same question. This is the same question. And same question. So at what time the results appear to be inaccurate? At what time the results to be inaccurate? This is the time. So this is time. So it is at 2 minutes. So at 2 minutes, during the first 6 minutes, the speed of the reaction decreases. How do you know that? At the beginning of the reaction, the first speed is fast, then it starts to decrease. How do you know? It's because it starts to flatten until it completely becomes zero. So it's decreasing. So it's decreasing by time. And the time passes, the initial concentration of hydrochloric acid decreases with one of the reactants. So the concentration, of course, decreases. And the frequency of the collisions also decreased because of the concentration decrease. Select the gap would be obtained if the experiment was repeated at 50 degrees. If you make the experiment at 50 degrees instead of having it at 25, this means that the rate of the reaction has increased, and the only thing that will show that it has increased if the curve is steeper. So here I don't choose this one because it become less, so it become less, so it means less steep, so I don't choose it. And this one, there are two which become steeper, one which ends at the same place and one which ends at a higher place. We didn't say that we do anything to make the amount more, so it will be at the same place. So this is the one that we choose. What is the best way to use the measure the volume of a gas? The gas syringe. Here I have a reaction H2O2. In this reaction, to do it correctly, you have to put a catalyst. Catalyst is manganese 4 oxide, MnO2 will break it into O2 and H2O. Don't forget to balance this one, 2 and 2 and 2. And this one, once it breaks down, decomposes into the oxygen gas and the hydrogen and the water. This is the hydrogen peroxide that people use with the coloring agents to dye their hair and make it brown or make it light colored. So the tube of manganese, why do I don't put the tube in the manganese? Manganese is a catalyst. I will not put it until I want the reaction to start. If I just leave the hydrogen peroxide by itself, it will not decompose, it will not break down. Only once I put the catalyst, it will start to break down. So the tube of the manganese oxide suspended to prevent the reaction from happening. The reaction will start only if I lift the thread. Once I remove the string, then it will fall down and the manganese will touch the hydrogen peroxide and the reaction will start. So at the beginning, I put it like that so that the reaction does not happen. And then once I remove the string, then it will start the reaction. The manganese acts as a catalyst to make only the reaction faster, but it's not one of the reactants. So it's only a catalyst to prevent the reaction, and the codon string is released are the answers. So when 1 gram of lumps of manganese oxide are used instead of powder at the beginning, it means it decrease the surface area. So once you decrease the surface area, the rate of the reaction will decrease because it has a smaller surface area. The reaction stops when the reactant, which is hydrogen peroxide, completely finishes, is completely consumed. There is a danger of explosion where the larger amount of dry powder combustible material is produced. We said that if you have any place where there's substance produced with a very small particle size, this is very dangerous because this can change any small reaction into a big reaction. Now, if you have a small spark due to any reason, and this spark will be magnified millions of times. Why? Because the spark is happening in a medium which is causing the reactions to be very fast. Why? Because the surface area is very high. Why the surface area is very high? Because this is very tiny particles, so like powdered in the air, and when you are having a mill or you're having a mine, then there is particles in the air which are very tiny. The surface area is very high, so a small spark can change into a very big reaction, which is an explosion. So when the concentration increases, the frequency of the collision increases. This leads to increase in the reaction rate.